Hello, I'm Carly McAvoy. I want to solve and graph compound inequalities today. So first we're going to start here by distributing, and we're going to solve inequalities the same way that you solve equations. So I'm going to bring the inequality over here, the variable over here, by adding 5x to both sides. That's going to give me 2x, and I'm going to subtract 12 from both sides. That's going to give me negative 7. And if I divide both sides by 2, I get x is less than negative 7/2. So there's one inequality solved. And the other one, I'm going to add 5 to both sides and get negative 2x is greater than 0 and divide both sides by negative 2. Because I divided by a negative, I'm going to reverse the direction of the arrow. Now these are the two graphs that I'm going to solve, and I have an AND statement, and that means I'm interested where would these two graphs intersect. So what I have is, my suggestion is that you draw both graphs and then you see where the intersection would be. I have this graph says that we're starting at negative 7/2 going to the left, and this one says that we're starting at 0 and going to the left. So I actually do have some overlap. Remember, I'm interested in where the graphs overlap. It overlaps, but it doesn't start overlapping until here, because from 0 until we get to this negative number, this is the only one that we see. So the graph, the overlap of the graph is what I'm interested in, and that's actually starting at negative 7/2 and going to the left forever. So in this case, it looks like we're just ignoring that other graph altogether, or that other equation. Well, sometimes that happens, that one graph shows the whole statement because that's the only part that overlaps. If I was to state this in set builder notation, I would say the set of all x such that x is less than negative 7/2. Even though I'm looking at both of these, this is my final answer. And an interval notation, I would say I'm going from negative infinity up to negative 7/2. And both of these would be parentheses because I don't have an equal to part and I never have a bracket on infinity. So that would be my final answer. Let's look at this one. I have an OR statement here. So now I'm joining two graphs together. I'm not looking for an overlap. But anyway, if I subtract 4 from both sides, I get negative 12. And if I divide both sides by 2, I get negative 6. I'm not reversing the arrow because I divided by a positive. Here I'm going to add 6 to both sides, and then I'm going to divide both sides by 3. And I get x is greater than or equal to negative 2. Again, I did not reverse the arrows on either one of those because I didn't multiply or divide by a negative. What I have here is I have a graph that's going forever to the left, starting at negative 6. And over here, I have a graph that's going forever to the right, starting at negative 2. Well, that's fine because I'm not looking for an overlap. I'm looking to combine those together or union those because of the OR statement. So what I have, if I put both of these on the same graph, I have negative 6 and I have negative 2. Notice that 6 is further to the left because it's less. Left is less. And so I'm going from here forever to the left. And over here I have a bracket because of the equal to part. And I'm going forever to the right. And that's what my graph is going to look like of my final answer. What does that look like as an interval? It looks like negative infinity up to negative 6 union with negative 2 to infinity. So that's interval notation. Set builder notation, I could say it's set of all x such that x is less than negative 6 and x is greater than negative 2. Greater than or equal to negative 2. So I could state that in a few different ways. All of that says the same thing. All right, let's look at number 3. I threw some fractions in here because I know you're going to encounter some fractions in your homework, and it's nice to see somebody work those out. What I do notice about this fraction problem is that 4 goes into 4 and 4 goes into 12. 3 goes into 6 and 3 goes into 15. So instead of clearing out the fractions, I'm just going to multiply because they're going to come out nicely. But just like an equation, if I wanted to, I could find an LCD and then multiply everything by the LCD. Remember that this number would also get multiplied by the LCD, And we would not multiply inside the parentheses. So if I wanted to multiply everything by 12, which is the LCD, I would say 5 times 12, 3/4 times 12, and 2/3 times 12, not inside the parentheses. But I'm not going to do that because I don't need to. So I'm going to go ahead and say 3/4 times 4. The 4's cancel. I get negative 3x. 4 goes into 12 3 times, and then 3 times 3 is 9, so plus 9. Feel free to do any of these type of calculations off to the side or on a calculator if you can't do them in your head. And then over here I have 3 goes into 6 twice, so 2 times 2 is 4x. And 3 goes into 15 5 times, and 5 times 2 is 10. So I've cleared those fractions out nicely. Now I'm going to combine my like terms. And then I'm going to move things so that the variables are on one side and the numbers are on the other. If I subtract 4x from both sides, I get negative 7x. And if I subtract 14 from both sides, I get negative 4. Divide both sides by negative 7. Remember, if you divide by a negative, you reverse the direction of your arrow, so I get 4 7s. Now over here, I'm going to just multiply both sides times 5, and I get x minus 13 is less than or equal to negative 15. I multiplied by a positive, so I didn't reverse the arrow. Then I'm going to add 13 to both sides, and I get x is less than or equal to negative 2. Now this time I have an AND statement. So again, I'm looking for where do they intersect. And the other other video that I have that shows you graphing gets you to this point and then has your graph. So it's nice to watch that one to kind of learn about the graphing. But what I have for this one is I have a graph that goes forever to from 4/7 and then forever to the right. And this one starts at negative 2 and goes forever to the left. So if you think about these on the same graph, here I have negative 2 and here I have 4/7. I'm going this way and I'm going that way. Where's the overlap going to be? Nowhere. There's no overlap. So this particular compound inequality, it cannot be solved. There's no solution to it because there's no overlap when I look at the two graphs. Okay, 4 and 5 I'm going to look at rather quickly. I just want to show you another thing that can happen with the OR statements. If you divide both sides by negative 3 here, hopefully you can see the arrow is going to reverse and I'm going to get 1/3. And if I add 1 to both sides here, I get 5x is less than 10. Whoops, just less than, no equal to part. And dividing by 5, I get x is less than 2. So in this case, I have from 1/3, I'm going forever to the right. And from 2, I'm going forever to the left. If you look at both of those on the same graph, you can see I'm going forever to the right, I'm going forever to the left. So this graph would just be the whole thing. I wouldn't need to show any numbers on there, but because I'm covering the graph forever to the right and forever to the left, and I'm not asking for overlap, I'm asking for a union, just put those two parts together, my whole graph looks like this, and my interval notation is just this, right? Going from negative infinity to positive infinity. Of course, no brackets on that. The last one I want to show you is a compound inequality as well. It's an AND statement, which can be written. So this is saying this is greater than this, and at the same time, this is less than that. So it's an AND statement, but it's a little different format. There's 3 parts, so when I solve this, I'm going to subtract 2 from all 3 parts. So I get negative 6 is less than negative 3/4 x is less than 3. Now I'm going to get rid of this by multiplying by negative 4/3, which is the reciprocal of my coefficient negative 3/4. Multiply by negative 4/3 and multiply by negative 4/3. Whatever you do to one part, you have to do to the both. Notice that we have 2 negatives to make a positive, and 3 goes into 6 twice, and 2 times 4 is 8. Now notice also that we multiplied by a negative, so I have to reverse that arrow. And then these two things go away because they're reciprocals of each other, and so I get just x, and then I have to reverse this one, and the 3's cancel, and I get negative 4. Now I'm going to rewrite this in a different order and say negative 4 because that's the number to the left, and 8 over there to the right. So I'm flipping it. Notice that x is greater than -4, while x is less than or equal to 8. So this one, when you get in this format, it's really pretty easy to graph because we're showing you x is nestled in between those two values. So I have from -4 to 8, it's greater than -4, but it's less than 8, which means for this particular AND statement, this is assumed AND or implied AND, I have an interval like this. The answer to that in interval notation would be -4 to 8, whoops, 8, not infinity, and there'd be a bracket at the end because of the equal to part on that end. It's possible that you solve this and you get something like x is greater than 4 but less than -8 or some crazy thing like that, and that would be no solution again. Your AND statement has to have a point where they overlap. The OR statement does not have to overlap. You can combine the two together. All right, have a fantastic day, and I'll talk to you next time.